Where we left off last time, we were looking at just the parent function of f of x equals the square root of x. Our pattern was the exact inverse of f of x equals x squared. So rather than over 1 up 1, over 2 up 4, over 3 up 9, it is now over 1 up 1, over 4 up 2, over 9 up 3. We can use that information to help us transform the graphs just like we've done in the past. If we want to translate, translations could be left, right, up, or down. It's going to follow a very similar pattern to what we've done in the past. Whenever we had plus or minus inside the parentheses with the x, that was our left and right movements, and it was always the opposite of the operation that we saw there. So if I have the square root of x plus 2, that means I'm going to move left 2. If I have the exact same thing, but inside I have x minus 2, that's going to be our shift right 2. Just like before, if we had a plus or a minus, a constant outside the parentheses with x, that was going to be our up and down shifts. The square root of x plus 3 means we're going to shift up 3 versus the square root of x minus 3, shift down 3. Be very careful, especially if you are a messy writer, that you make sure that you can see where those radical signs are. Is it going over the 3 or not? Because that does change which direction that we are shifting. Reflections are going to follow, again, a very similar pattern to what we've done in the past. If you have a negative on the outside of the square root, this is going to be a reflection in the x-axis. Which is a vertical flip. That's the typical type of flip that we'll be talking about throughout this unit because our y values change. When our y values became their opposite, it was a reflection over the x-axis. Whenever I have the square root of negative x, that's going to be a reflection in the y-axis, which is our horizontal flip. We'll talk about this for sure, but it's not going to be something that we do quite as often as the other type of reflection. Our last thing is a vertical stretch or even a vertical compression. We're only going to worry about the vertical stretch and compression, which means that our constant is going to be in front of the radical. So we're looking at k times the square root of x. If it was a horizontal stretch or compression, you could put a coefficient in front of x, but we're not going to do that in this unit. Just like before, the absolute value of k is greater than 1, we'll see a stretch, and if the absolute value of k is less than 1, we'll see a compression. And the reason we're using the absolute value is because the negative values don't determine a stretch or compression. The negative values determine whether there's a reflection or not. So you do have to have a pretty good idea of what your pattern looks like whenever you graph to be able to do transformations. It does help me to kind of write out what's going to happen. And honestly, all you need to worry about is your vertex and then follow your pattern. Underneath the radical, I have minus 3, so I know it's a horizontal shift. And it's always the opposite of what I see. So I see minus 3. So this means I'm going to shift 3 units right. So normally in my parent function, my vertex is at 0, 0. All I'm going to do is shift 3. 1, 2, 3. That is my new vertex. And then everything else is going to be the exact same. I go over 1, up 1, over 4, 1, 2, 3, 4, up 2. Remember, it's from the vertex. Over 4, up 2. There's my new point. I'm going to just connect those. And then I'm going to draw the line to connect those dots. It is going to form kind of an arc. We can talk about end behavior. Each of these, we could also talk about domain and range. So domain for this one is going to be 0 to infinity. 3 to infinity. And our range is going to be 0 to infinity. It is an increasing function because it is going up from left to right. There is, in our class, we're going to say there is no left end behavior. And then as we move to the right, so as x approaches infinity, y also approaches infinity. And that's what those arrows mean. It means approaches infinity. I'm sorry. Even though I'm doing a video, sometimes you still have to remind me that I have to move my paper so you can see it. I apologize. Looking at number 2, I have the square root of x plus 4. When it's outside the radical, that's my vertical shifts. So this is going to be up 4 units. So my vertex at the parent function 0, 0. So I'm going to go up 1, 2, 3, 4 and put my new vertex. From there, follow the pattern. Over 1, up 1. Over 4, 1, 2, 3, 4, up 2. You can create the square root function. My domain for this one is 0 to infinity. My range for this one starts at 4. So it's 4 to infinity. This is also an increasing function. There is, again, no left end behavior. And then as x approaches infinity, y also approaches infinity. So those are some pretty basic ways to describe end behavior, and you're going to see pretty similar type things written. Over here, I have, in number 3, the opposite of the square root of x. So thinking about where that might be, I don't have any vertical or horizontal shifts. So my vertex is going to stay exactly where it is. But now, because I'm shifting and I'm reflecting in the x-axis, so typically my function's up here, now it's going to be down here. So instead of going over 1, up 1, I'm just going to go over 1, down 1. Instead of over 4, up 2, I'm going over 4, down 2. And then I can draw my not so pretty square root of x function. You could fill in here reflect in the x-axis. The domain for this function is again 0 to infinity because we did not shift it anywhere. The range is a little bit different. It's actually a decreasing function because it's going down as you move from left to right. So the lowest value that the range is going to be is negative infinity. So you do need to start with negative infinity, and then it goes up to 0. Again, there is no left end behavior. And as x approaches infinity, y is approaching negative infinity, which shows that it is a decreasing function. We're going to move to page 8 and continue doing a few examples. This transformation, the negative is underneath the radical. So this is where we're going to have a reflection in the y-axis. There's no vertical or horizontal shifts. So I'm going to put my first vertex at 0, 0. Instead of going right 1, up 1, I'm going to go left 1, up 1. Left 4, 1, 2, 3, 4, up 2. And then I have my function going to the left. My domain for this function, x goes, or my domain functions, my x values, go from negative infinity to 0, with 0 being inclusive. My range values start at 0 and do go up to infinity. There is no right end behavior, since it stops on the right. So as x approaches negative infinity, y is approaching infinity. For number 5, now we have multiple things going on. So what I would suggest doing first is looking for your shifts. We know that there is going to be a shift left 3 units. We also know there's a vertical stretch of 2. So I'm going to start at my normal 0, 0 vertex, and I'm going to shift 3 left. 1, 2, 3, and I'm going to put my new vertex. So now we got to think about our vertical stretch of 2. Typically, with this function, we have to go over 1, up 1, over 4, up 2. But now all of these are going to get multiplied by 2 because we have a vertical stretch. So I'm going to go over 1, up 2. Over 4, 1, 2, 3, 4, and I'm going up 4, 1, 2, 3, 4. So you can actually see the vertical stretch. It's getting taller as we go along. There is no left end behavior. And then as x approaches infinity, y approaches infinity. We can quickly write down our domain. Our domain values go from -3 to infinity. Our range values go from 0 to infinity. Again, there's no left end behavior. And as x approaches infinity, y also approaches infinity. We got one more kind of similar. This one's going to have the factor up front. This is going to be a vertical compression of 1/2. So it means it's going to be half as far from the x-axis. So I'm going to put my same vertex because there's no vertical or horizontal shifts. Typically, I go over 1, up 1. But I'm going to do it over 1, up 1/2. Over 1, up 1/2. Typically, it's over 4, up 2. But now I'm going to do that 2 times 1/2. So it's over 4, 1, 2, 3, 4, up 1. The graph becomes much shorter. Our domain values are 0 to infinity, and our range values are also 0 to infinity. It's an increasing function. There's no left end behavior, and then as x approaches infinity, y also approaches infinity. We have 2 more quick functions to do. In fact, I'll probably just do the first one with you, then you can try the second one. So this is not in graphing form the way we have it right now. And if you look at it, we've got a horizontal shift. We also have a horizontal stretch, but we haven't really talked about that. So try to think of another way we could go about it. If I look underneath the radical, I can factor what I have underneath by taking a 4 out of both of those terms. So 4 times x minus 3, 4x minus 12. If you think about this as just being 4 times something, I can take the square root of 4 and it pulls a 2 outside of the radical. So I have 2 times the square root of x minus 3. So now we know what we can do. We have a horizontal, sorry for my spelling, a horizontal shift of 3 to the right, a vertical stretch of 2. So I'm going to come back to my graph, and again, this is what I'm graphing. F of x equals 2 times the square root of x minus 3. My horizontal shift of 3 to the right, so I go 1, 2, 3, and I put my new vertex. There's no up or down movement. I'm going to go over 1, up 2. Over 4, 1, 2, 3, 4. Typically I go over 4 up 2, but I have to double my up. Over 4, up 4. 1, 2, 3, 4. And that should be your graph. Your domain is going to be from 3 to infinity. And your range goes from 0 to infinity. There is no left-end behavior. And then as x approaches infinity, y approaches infinity. Take a quick minute, pause the video, and see if you can do this next example without me. Hopefully you took a minute to try it. I'm going to quickly go through what we would do. I can take a 9 from both 9x and from 36. So I have 9 times x plus 4. The minus 5 is outside of the radical. The square root of 9 is 3. So this means I have to shift 4 left. I shift 5 down, and then I have a vertical stretch of 3. So when I come back over here, I'm going to go from a normal vertex of 0, 0, 4 left, 1, 2. Sorry, 1, 2, 3, 4. And then I'm going to go down 5. 1, 2, 3, 4, 5. And then from there, you follow your pattern, but remember you're tripling how you're moving vertically. So I go over 1 instead of up 1, over 1, up 3. Over 4, 1, 2, 3, 4, up 2. Instead of 2, I'm doing 2 times 3, so I have to go up 6. 1, 2, 3, 4, 5, 6. And then you just draw your pattern.